Picture a firefight in deep space. What do you see? Blaster bolts zipping past, ships exploding in massive fiery blossoms. It's an image we all know from science fiction. The only problem is, it's almost entirely wrong. So, what really happens when you pull the trigger in the silent, unforgiving vacuum of space? The results are stranger, more lethal, and way more interesting than anything Hollywood has dreamed up. From bullets that literally never stop to explosions that don't go boom, the laws of physics turn familiar weapons into something completely new. We're counting down 10 weapons that would work very differently in space. Conventional guns, pistols and rifles. Let's start with the basics. A standard handgun or rifle. First question, would it even fire in space? The surprising answer is yes. Modern firearm ammo contains its own oxidizer, a chemical that lets the gunpowder ignite without any oxygen from the atmosphere. So, pulling the trigger works just fine. But that's where the similarities end. On Earth, you feel a kick, but friction and gravity help keep you planted. In zero gravity, Newton's third law, for every action, there's an equal and opposite reaction, takes over with a vengeance. The force that sends the bullet forward also sends you backward. The push from a single pistol round is manageable, maybe sending you back at a foot or two per second. But firing an automatic weapon? That would be a nightmare, sending you into a helpless, uncontrollable spin. It gets worse. All that ignited gunpowder creates a cloud of residue and lead dust. In a sealed spacecraft, that's a toxic, potentially explosive mess floating around you, requiring something like an explosion-proof vacuum to clean up. And the bullet itself? With no air resistance to slow it down or gravity to pull it down, a bullet fired in space will just keep going and going. It'll travel in a perfectly straight line at a constant speed, forever, unless it hits something. And if you're not careful in low Earth orbit, that something could be you. Fire a bullet in just the right direction, and it could circle the entire planet and come back to hit you from behind. Shotguns. Okay, so a single bullet is tricky. What about a whole spray of them from a shotgun? On Earth, a shotgun blast spreads out in a cone, which is what makes it so devastating up close. That spread is caused by the pellets jostling each other, but it's really amplified by air resistance. In the vacuum of space, you take away the air, and the spread is drastically reduced. The cluster of pellets would rocket out of the barrel and stay in a tight, dense group for a much longer distance. Instead of a wide spray, you'd basically have a single massive slug flying at thousands of feet per second. It turns the shotgun into a terrifying, clumsy, long-range weapon it was never meant to be. And the recoil, which is already a beast on Earth, would be a huge problem in zero-G, sending an unbraced shooter tumbling backward. Explosives, grenades and bombs, space explosions are another huge sci-fi myth. We see giant, bright fireballs and hear deafening booms. The reality is silent and just weird. An explosion is just a rapid expansion of gas. On Earth, that expansion creates a shock wave that travels through the air, carrying all the destructive force. In a vacuum, there's no air, no shock wave. So, what happens? The chemical explosion still happens since most explosives pack their own oxidizer. But instead of a fiery shock wave, you just get a rapidly expanding cloud of superhot gas and shrapnel. The only way you'd see a classic fireball is if the exploding object, like a spaceship, rips open and releases its own oxygen supply, which would then burn up in a brief flash. The damage comes purely from the debris. If you're in the path of the fragments, you get shredded. If you're standing just outside that path, you're completely unharmed. No boom, no blast wave, just a silent, deadly cloud of projectiles that will keep traveling forever. Flamethrowers. A flamethrower seems like the last thing that would work in space. Fire needs oxygen. Space has none. Case closed, right? Not exactly. A traditional gasoline-based flamethrower would be completely useless. But a flamethrower just shoots a stream of burning liquid, and the key is what that liquid is. Many modern incendiary fuels are actually mixed with an oxidizing agent, which lets them burn even in low oxygen environments. But the effect would be bizarre. On Earth, fire billows and rolls because it's mixing with the air. In a vacuum, you wouldn't get a stream of fire. You'd get a stream of burning liquid that would probably break up into individual fiery blobs because of surface tension. These blobs would fly in a straight line, burning until they run out of fuel. It's less of a wall of fire and more like a high-speed squirt gun of burning death. Melee weapons, swords and knives. In a world of hyper-velocity projectiles, why would anyone use a sword? Sci-fi worlds like Dune have answers like personal shields. But let's just look at the physics. Melee combat in zero-G is a terrifying concept. On Earth, fighting is all about gravity and leverage. You plant your feet to throw a punch or swing a sword. In space, that's all gone. If you push an opponent with a sword, you'll also push yourself away. A powerful swing would send you spinning in the opposite direction. Combat would become a horrifying ballet of physics. The best attacks would be stabs, since they require less leverage. Grappling would be critical, as fighters would try to anchor themselves to something or someone to deliver a real blow. In this environment, a simple knife could be deadlier than a gun if it causes a suit breach, leading to a slow, silent death in the vacuum. Lasers. They're the classic sci-fi weapon, and for good reason. They're one of the few weapons that would actually be more effective in space. On Earth, a laser beam gets weakened by dust, moisture, and air molecules. In the vacuum of space, there's almost nothing in the way. A laser beam can travel for incredible distances with very little loss of power. And unlike the movies, you wouldn't see the beam at all unless it hits a stray puff of gas. It would be a perfectly invisible, instantaneous line of energy. Damage is done in two ways. A continuous beam can heat a target until it melts, while a pulsed laser delivers short, high-energy bursts that create a physical shock, basically drilling into the target. The only real limits are power and range. Over vast distances, even a laser will spread out and lose its punch. Defenses would probably involve things like mirror-like hulls, or spinning the ship to keep the beam from focusing on one spot. Railguns. A railgun is a weapon that uses electromagnetic force, not gunpowder, to launch a solid metal slug at mind-boggling speeds, way faster than any conventional gun. In space, they are terrifyingly practical. With no air resistance to slow it down, a railgun projectile keeps its immense kinetic energy until it hits something. A slug hitting a target at several kilometers per second delivers an impact equivalent to its own weight in TNT. Unlike an explosive, a railgun's damage is focused. It wouldn't create a big boom. Instead, the hypervelocity slug would punch clean through a target. It might just zip straight through, leaving a couple of small holes that could lead to explosive decompression. Or, if the slug is designed to break apart on impact, it could create a devastating storm of shrapnel inside the ship. The biggest challenge isn't making them work, it's powering them. They need a colossal amount of electricity, which is a major design puzzle for any spacecraft. Kinetic rods, rods from God. This weapon is thankfully still theoretical. The concept, often called Rods from God or Project Thor, is simple and horrifying. A satellite in orbit releases a dense tungsten rod about the size of a telephone pole. It's not explosive. It doesn't need to be. Guided by small fins, it falls out of orbit toward a planet. As it plummets, it reaches hypersonic speeds. The sheer kinetic energy on impact would be equal to a small tactical nuclear weapon, able to punch hundreds of feet underground, but because it's just a metal rod, there's no radioactive fallout. While the Outer Space Treaty of 1967 bans weapons of mass destruction in orbit, these kinetic rods exist in a weird legal gray area. Bows and arrows. Of all the ancient weapons, the bow and arrow seems like one of the most useless for space combat. But would it even work? Yes, and the results are surprisingly complicated. The bow itself works on pure mechanics, storing and releasing potential energy, so no oxygen is needed. However, actually using one in zero gravity would be a lesson in physics. To draw the bow, you pull the string back, but without gravity or ground to brace you. Newton's third law dictates that pulling the string toward you would also pull your entire body toward the bow. An archer would have to be securely anchored to a surface just to draw it. Once fired, the arrow would fly straight forever, since there's no air resistance to slow it or gravity to make it arc. But there's another problem: stability. On Earth, the feathers, or fletching, on an arrow use air resistance to keep it flying straight. In a vacuum, the fletching is useless. Any tiny imperfection in the release would send the arrow tumbling end over end, making it more likely to hit a target with its side than its point. Anti-satellite weapons, ASATs. Finally, we have a category of space weapons that already exist and have been tested. Anti-satellite weapons, or ASATs. These are designed specifically to destroy satellites. Some are kinetic kill vehicles, basically missiles that just ram into a satellite and shatter it. Others are more subtle, like high-powered lasers that can blind a satellite's sensors or fry its electronics. The biggest problem, especially with the kinetic kind, is the mess they make. Destroying one satellite creates a massive cloud of space debris, thousands of tiny pieces of junk all traveling at orbital speeds. Each piece becomes a tiny projectile that can destroy other satellites, leading to a chain reaction called the Kessler syndrome. This could render entire orbits around Earth unusable for generations. This is a very real concern, and it's why many are pushing for treaties to ban their use. So, the next time you see a flashy space battle in a movie, you'll know the reality is way stranger and, honestly, more terrifying. The simple absence of air and gravity rewrites the entire rulebook. A bullet becomes an eternal threat. An explosion loses its voice, and a simple metal rod can become a weapon of mass destruction. While many of these are still theories, they highlight the incredible challenges that await us as humanity pushes into the final frontier. The weaponization of space isn't a distant sci-fi concept, it's a conversation that's happening right now. One thing is for sure: space will always be a dangerous and unforgiving environment, where the laws of physics are the ultimate arbiter of life and death. The physics of space combat forces us to rethink everything we know about warfare. What other weapons do you think would get completely weird in a zero-G vacuum environment? Let us know your ideas in the comments below. And if you enjoy exploring the line between science and science fiction, make sure to subscribe so you don't miss our next video.